In this video, you're going to learn how to build a full-stack dApp on the Ethereum blockchain using Solidity and React. Now, just this week, I released a new blog post called The Complete Guide to Full-Stack Ethereum Development that's performed much better than almost any post I've ever written with over 50,000 views. So I figured why not turn this into a video course as well and kind of walk through how to do this end to end. So that's what we're going to be doing in this video. We're going to start from scratch, creating a brand new React application and building everything out step by step from there. We're going to build out and compile a couple of different smart contracts and look at how to actually deploy these smart contracts to our local network as well as a real test network. In our React front end, we'll build out a basic application that will show you how to read data from a smart contract as well as write data to a smart contract that has been deployed to the blockchain. Everything that you need to know to kind of get started with the stack should be covered here in this video. So I hope you learn a lot, and I hope you learn as much as I did creating all of this stuff when I first learned how to do all this stuff. So with that being said, let's go ahead and get started by creating our brand new React application from our terminal. To get started, we'll create our React app by using npx create React app. All right, next we'll go ahead and change into the new directory. And we'll go ahead and install the dependencies that we're going to need. And you can use either npm install or yarn add to go ahead and add these dependencies. So let's go ahead and walk through what we're adding here. First, we're going to be adding the Ethers.js library, and this is going to be what we're going to be using from our front end to interact with our smart contract. We're also going to be installing some dependencies that our Hardhat development environment is going to depend on. And that's kind of what the rest of these are. We're going to install Hardhat. We're going to install Hardhat Waffle. We're going to install Ethereum Waffle, Chai for testing, and then we're going to install Hardhat Ethers. So go ahead and install all of these as I have them shown here, or you can link to the workshop and the tutorial in the comments here and kind of copy and paste. Once everything has been installed, we'll go ahead and initialize our Hardhat environment. Now this is going to be our Ethereum development environment. This is going to go ahead and create a basic project with all of the configuration that we're going to need. It's going to even create a basic smart contract for us to start working with. So to do that, let's go ahead and run npx Hardhat. Now what we're going to do is choose create a sample project. We'll take the default for the project root. And then we'll choose yes for git ignore. Now, once this is created, we should be able to go and look in our directory and see that we have a new folder called contracts, as well as a file called hardhat.config.js. And we can go ahead and open up this project now in our text editor and take a look. All right, so once we open the project in our text editor, I'll go ahead and zoom in there a little bit. Let's go ahead and take a look at this configuration file. In the configuration file, you're going to basically see a couple of different things going on. First of all, there's an import. There's a very basic Hardhat task, and you can configure additional tasks here in the configuration. And most importantly for us is this module.exports. This is going to be kind of where the configuration lives for our project, and we're going to be updating a few things here. First of all, we're going to be basically setting up different networks for us to deploy to and test out, and we're going to also maybe be modifying the Solidity version that we're going to be working with. So let's go ahead and do that now. So instead of 7.3, let's go ahead and bump this up to 8.3. Now this is April of 2021, so this is kind of like a fairly new version. In the future, you might even bump this up even a newer version. The next thing that we're going to do is we're going to go ahead and set the paths for our artifacts. Now, since we're in a React application, we're going to be working directly from this SRC directory. Now, when we compile our project using Hardhat, it's going to take all of our smart contracts and it's going to create some machine-readable code called ABIs and additional artifacts as well that we're going to basically be needing. And we want those artifacts to go in our SRC directory so we can import those from our React app. So what we're going to do is we're going to go ahead and paste in or set in a configuration called paths, and we're going to set the artifacts directory to /src/artifacts. Now, when we run npx hardhat compile, all our compiled code will go in the src directory, and we'll be ready to start interacting with it from our front end. The next thing that we're going to do is there is a Hardhat configuration setting that we need to go ahead and set up now for our local network. So we basically want to say, we have this networks key, and this is going to be something that we can configure later on to add additional networks. So for instance, there is the main net for Ethereum that you can deploy to, but you can also deploy to test nets. And that's what we're going to be doing. We're going to deploy to a test net using Infura later on. But for now, we're also going to be setting our Hardhat network, which is kind of our local network. We want to go ahead and set the chain ID to be 1337. This is specific to kind of the way that Hardhat works. And this is just something you need to do to make everything work. So with that being said, let's go ahead now look in our contracts directory. This is going to be where we write all of our Solidity code. And if you look right now, you're going to see a basic contract called greeter. And we're going to compile this and we're going to be interacting with it. Now the contract, and we can go ahead now and set our Solidity version to 8.3, and we should see that this error goes away because that's the version that we've set in our configuration. Now, this contract is pretty basic. We have a constructor that basically console.logs that, hey, we're deploying a greeter with a greeting of greeting. And when we deploy this contract, we're going to need to pass in a value here as part of the initialization into this constructor to kind of set the greeting to be the greeting. Now, how do we do that? Well, on our front end, we're going to be making a function call, passing in a string. But when we actually deploy this, like to update that, here in setGreeting. But when we deploy this, we actually need to pass that string in as we deploy. And when you're deploying this contract, you're going to be doing so locally from a script that you're going to be running from your project. Now, thankfully, the Hardhat development environment actually created a sample script for us. So if we go in scripts/sample script, you're going to see that we have some code kind of already written for us that will allow us to go ahead and deploy this contract. So I'm going to go ahead and kind of delete some of these comments and kind of like minimize this a little bit. And this is what is going to be deploying our contract when we want to deploy. So first of all, we get a reference to the contract that we would like to deploy. In this case, it's the greeter contract. We then say greeter.deploy, passing in the constructor text that we want to pass in this case, hello Hardhat. And then we wait for this to actually be deployed, and then we just console.log to the terminal, the actual address that we're going to be deploying to, and we're going to be using that address in our front-end app. Now, what might make sense, since this is a deploy script, instead of calling it sample script.js, let's rename this maybe to something like deploy.js. And in a moment when we want to deploy this, we can actually run the actual scripts/deploy, which kind of makes a lot more sense, right? So let's go back to our Solidity code. And other than our constructor that's going to set the greeting to be whatever we pass in right here, which in our case is going to be hello Hardhat, we also have two functions. One is greet. That's going to basically return the greeting. It's just going to return a string. Now in this greet function, you'll notice the public and the view keywords. Public means that this function can be read from outside of the smart contract, for instance, from our front-end React application. And view means that we are not modifying any states. We're not writing anything to the blockchain, but we are reading from the blockchain. Now, if we were not reading from the blockchain and we just wanted to return a hard-coded value, you could use something called a pure function. And there are a few different other types that we're not going to be really needing to cover at this moment. We also have the setGreeting function. Now, the greet function returned a string, but this function is not going to return anything. So you'll notice that we don't have a returns value here, but we do have an argument of greeting that we did not have when we were just calling the greet to return the greeting. So all we're going to basically doing here is updating the value of greeting to be what's passed in as an argument, and we're just going to also console.log that we're doing this. So now, when we deploy this contract, it's going to deploy with an initial value of whatever we pass in our deploy function. So in our case, it's going to be hello Hardhat. and we're going to have a function that can read that value, and then we have a function that can set that value. Now, when this set greeting function is called and someone invokes that, they're going to need to actually pay some type of gas for this transaction to be written. So in that case, for that to work, we're going to be installing a wallet, which is going to be MetaMask, and we're going to be using the Ether that is going to be created for us by Hardhat in our local environment. Now, with that being said, let's go ahead and maybe compile this smart contract. Now, in the SRC directory, we configured our Hardhat to write artifacts to src/artifacts. So let's go ahead and make that happen. Let's go ahead and compile. So to do that, I can go back to our React application and I can run npx hardhat compile. And this should go ahead and compile our smart contract into an artifacts directory. So now in SRC, you should see that you have this artifacts directory here. And what we're going to be interested in is the contracts/name of the contract.json. And specifically within this, we're going to be looking for this ABI. And ABI stands for Application Binary Interface. And this is where we're going to be importing in our front-end application to interact with it. And to do that, we can basically import like the artifact/contract/greeter.json. And then we can kind of say whatever that value is, .abi is kind of the ABI that we're going to be working with. Now that we've created our smart contract, or we've looked at the smart contract that was created for us by Hardhat, and we've actually gone ahead and compiled this, let's go ahead and deploy this to an actual blockchain. And the first blockchain that we're going to be compiling and deploying to is going to be a local node that we're going to be running that Hardhat gives us. And we can start that node just by going back to our CLI and running npx hardhat node. And this should go ahead and create a local test network, and it should go ahead and also give us 20 or so accounts that we can work with. So here, once deployed, you'll see that we have accounts, account 0, account 1, etc., etc. And we have our account number or account ID as well as a private key. We're going to be using both of these things in just a moment when we start interacting with our front-end application. So now that our node is running, let's go ahead and keep that running. And maybe I'm going to be getting account 0 information in just a moment, so I'm going to keep that handy. I'm going to go ahead and start another window or open another window. And now I want to go ahead and deploy this contract to that network. So the way I can do that is I can run npx hardhat run scripts. I can say scripts-deploy.js, and I want to go ahead and set the network to be localhost. So when we deploy this, we can go ahead and hit enter and deploy this. You should see that you have logged out greeter deployed to, and it gives you the address of the smart contract. And if we go back to our node, we should actually see some stuff logged out, kind of letting us know that everything was deployed. We see the gas used. We see the contract address, the transaction, who it's from, and all of this information. So that's pretty cool. And we even see the console.log message that we wrote in our smart contract there. So that's pretty nice. So we have all this stuff logged out to us. We've deployed our contracts successfully. And we might even notice that if we go back up to our first account in just a moment, that it does not equal 10,000 ETH. So you're going to notice that we use some of that ETH to deploy this contract, which is pretty interesting. So now that we have all of that going on, what we want to do now is let's go ahead and use MetaMask to connect to this account here. And to do that, let's go ahead and open up a Chrome window, and we're going to go ahead and install the MetaMask extension. So to do that, I'm going to go ahead into Chrome and go ahead and search for MetaMask Chrome extension. And I'm going to go ahead and download now and install MetaMask for Chrome and then add to Chrome. All right, so once MetaMask is installed, we can go ahead and click Get Started. And I'm going to be setting up a brand new wallet. So let's go ahead and do that unless you have an imported wallet that you want to go ahead and import. So let's go ahead and click Create a Wallet. And I'm just going to, go along. I agree. And I'm going to go ahead and create a password. Agree to the terms of use and click Create. Now this is going to go ahead and give us our backup phrase. So if this is your first time using MetaMask and you want to continue using this exact wallet, then be sure to go ahead and save this somewhere and keep it handy somewhere. But I would kind of recommend maybe for this testing to go ahead and just create a single account like we're doing here and maybe just get rid of it later and not put any real money in it. That's kind of what I'm doing here. So I'm just going to click Remind Me Later because I don't really care about that. So now that we've gotten MetaMask installed, I'm going to go ahead and go to my extensions. I'm going to go ahead and pin MetaMask to my extensions. So I'll also always see it here for me, okay? And when we open MetaMask, you should see that we're on the Ethereum mainnet. But what we actually want to connect to is our localhost, that network that we've go ahead and created and run locally. So I can go ahead and click that. And you'll notice that we're now on localhost 8545. And I can go ahead and look at the accounts that I have by clicking up here. And right now you're going to notice that we have one account that doesn't have any money in it. So what we want to do is let's go ahead and import that account that we have created here. So I'm going to go ahead and copy this private key here. I'm going to go back to MetaMask. And I'm going to go ahead and click Import Account. I'm going to paste the private key here. And I'm going to go ahead and click Import. And now you can see we have our new account with 9,999.996 ETH left after deploying our contract, where we did have 10,000 and now we have a little less. So this is the account that we kind of have that we've deployed from. And we'll be using this, more in just a moment. Now that we've already kind of gotten all that set up, let's now connect our React application and maybe start interacting with this smart contract. So to do that, let's go ahead and maybe open up our terminal again and go ahead and first off, maybe go ahead and start the app. So I'll go ahead and run npm start. And this should go ahead and open up, a local host 3000 with the app running there. And then also what I'm going to do is I'm going to go ahead and open up src/app.js, and this is where we're going to be writing our code. So should open up in localhost 3000. Okay, cool. So this is the app. Nothing going on there yet. We're not going to be really creating like a really nice UI or anything. I think the really general idea here is that we want to go ahead and create something that just shows how to interop with all of this stuff. So the first thing that we're going to do is let's go ahead and import useState and just useState from React. And we're going to also import the Ethers library from Ethers.js. Let's also go ahead and import, I guess we can leave app.css. Let's go ahead and import the ABI that we're going to be working with. So greeter from artifacts/contracts/greeter.json. Or actually, no, I think it's greeter. Well, let's see here. Yeah, greeter.json. Well, actually, you know what? It's greeter.sol/greeter.json. Okay, cool. Yeah, because we have contracts/greeter.sol/greeter.json. That makes sense. All right, so what we want to do now is let's go ahead and store our contract address in a variable. So I'm going to go ahead and say const greeter address. We're going to set this as a string. Now I can get that address if I go back to my terminal and I kind of go to where we deployed our contract. I can go ahead and copy this to my clipboard. And I'm going to go here and paste it in. So now we have that there and we can go ahead and continue on, and we'll be using that in just a moment. So what I want to do here is I want to say const greeting set greeting value and set that to use state. And what we're going to basically be doing is kind of giving the user a form input, and they're going to be able to write a greeting that they can then write and overwrite the value in the blockchain. The next thing that we're going to do is let's go ahead and create a function called fetch greeting. We're also going to create a function called set greeting. And we're making these async because they're asynchronous in the sense that they're going to need to await some return value. And we're also going to create a function called request account. A request account is going to connect to the MetaMask wallet of the user when we need to go ahead and create a transaction. So the first thing that we might want to go ahead and do is let's look at fetch greeting. Fetch greeting is a pretty basic function, so let's go ahead and walk through it. What we're going to first do is we're going to say if window.ethereum is not undefined, meaning that it exists, then we want to continue on. And all this really means is we are looking for the MetaMask extension to be connected. So if MetaMask is installed on that user's browser, then window.ethereum will be injected into the window object. So you can always count on window.ethereum to be there if that user is using MetaMask. Of course, there's other logic you could put here. This is a pretty basic example, but this is a good way to kind of see if they're using MetaMask. So if they are using MetaMask, we can continue on. And what we're basically going to do is we're going to create a new provider using Ethers, and we need to just pass in the window.ethereum value here, and we can say new ethers.providers.web3 provider. Now there's a few different providers and they do different things, but for our scenario, for our use case, we're going to be using the Web3 provider. Once we have the provider, we can now create an instance essentially of the contract by saying new ethers.contract, passing in the address, passing in the ABI from the compiled contract that we imported here, and then passing in the provider. And then now using this contract variable, we can say contract.greet, and we can take that as the value that we're reading from the blockchain. So in this case, this is going to be the greeting value. And once this value comes back, we're just going to maybe log it to the console. Of course, you could maybe update the UI to kind of show that value or something like that if you want, but I'm trying to make this really as concise as possible. And I am assuming some front-end knowledge here in the sense that if you wanted to update that UI, you would need to kind of update an additional piece of state. You could create another use state value here and then render that in your UI. So fetch greeting is going to be something we attach to a button in just a moment. Next thing that we're going to do is we're going to go ahead and have this request account method, or this request account function. And what this is going to do, it's going to request their account information from their MetaMask wallet. So we're going to say window.ethereum.request, and we're going to pass in the method to be request accounts, or ETH_request accounts. And this is going to prompt the user to connect one of their MetaMask accounts if they haven't already connected. And this will also, if you would like to, return an array of accounts. So the next thing that we want to do is create a function for setting the greeting. So to do that, let's go ahead and add some code here. The first thing that we're going to do is we're going to first check to make sure they've actually typed in a greeting, because if they haven't, we don't want to write an empty string to update anything. We also now check if window Ethereum is there as well, and if it is, we continue. We now wait for the user to go ahead and enable their account to be used, and once they've connected their wallet, we continue. We create another provider, but what we're now doing here that's a little different is that since we're going to be creating an actual update to the blockchain, we need to have a way to create a transaction, and to do that, we need to sign the transaction using a signer. So once we've created the provider, we can now create a new variable called signer by calling provider.getSigner. We now get a new instance of that contract, and instead of passing in the provider as the third argument here, we're passing in the signer. We then call contract.setGreeting. And here we're actually passing in the greeting variable that is local. So this is basically going to be whatever the user types into the form to update the greeting. And then we say transaction.wait. And this is basically waiting for the actual transaction to be confirmed onto the blockchain. So in a test environment, this is going to return very quickly. In a production environment, this is going to take a little longer to actually write to the actual real network. And then we call fetch greeting again, which is going to go ahead and log out the new value. So we're kind of like creating that transaction. We're waiting for it to continue to finish being written. And then we're going to fetch the value again and log it out just to make sure everything is working. Now, in our actual UI, we're going to be doing really basic stuff. We're just going to have a couple of buttons. So let's see here. Yeah, we can go ahead and delete all this stuff. Well, maybe I will leave the header. Either way, it doesn't really matter a whole lot. The header has some styling that I'm going to keep. So we're going to have a button for fetching the greeting. So we're going to say on click fetch greeting. This is going to be when a user, of course, clicks on the button. It's going to go ahead and invoke the fetch greeting function, which is going to do all the stuff we talked about just a moment ago. We also have a function for setting the greeting. So this is going to call the set greeting function, and we're going to need to have typed in a value to the input form to go ahead and update that. And then finally, we have an input field. And let's go ahead and take a look at what's going on here. The input field has an on-change handler, meaning that when the user is typing, the on-change handler is going to fire, and we're going to call set greeting value, which is going to update that local greeting value with the event.target.value, which is kind of anything, whatever is written to the UI. The placeholder that we're going to have is set greeting, so kind of tells the user what's going on. And you know what else we might do to make this just a little bit better is after we've created a transaction, we might say, we can do that right here. We might say set greeting value and just go ahead and reset that to an empty string. And then we can set value is equal to greeting into the input. This is kind of not 100% necessary. It's just a way for us to go ahead and update the UI once the greeting has been reset to an empty string. So with that being said, we should be able to go ahead and test this out. So I'm going to go back to my React app where we have this really basic form, and I'm going to go ahead and open the inspector and the console here. Okay. So if I go ahead and click fetch greeting, I should see hello Hardhat, which is exactly what we expected because that's what we deployed our contract with. So now I want to go ahead and reset the greeting. So I'm going to say hello from new greeting. Oh, it looks like I need to update something really quickly in our React code. When we created the initial value for greeting, let's go ahead and update that to an empty string, and then we should be good to go. All right, so the new greeting is going to be like hello from new greeting or whatever you want to call it. And we're going to go ahead and click set greeting. So as you see, we now have our MetaMask wallet opening, which is cool. And I'm going to go ahead and choose to use the account that we imported a moment ago. So I'll go ahead and click next, click connect. And now we're going to actually be paying for this transaction. And we're going to be using the gas price in the form of GUI, which is kind of a subset of ETH in a smaller value. So I'm going to go ahead and change the gas limit or leave it as is. It doesn't really matter. And go ahead and click confirm. So this means that we've actually gone ahead and written a new value to the blockchain. So that means everything is working. And if I go ahead and click fetch greeting, I should see that the new value is there, whereas the old value was hello Hardhat. And if I refresh and I click fetch greeting again, we should see that we have our new value. And I can say updated again and set the greeting again. And this time it's going to automatically have us connected because we already kind of connected our wallet. And now all we need to do is confirm the transaction. And now we've updated it again, and we click fetch greeting. We now get updated again. So that's pretty cool. That means that we've now deployed. We're now reading data, and we're also actually writing data. So what we've done so far is we've deployed to a local test network. What we now might want to do is we can actually deploy to a real test network. So there's a few of them out there. One of them is called Ropsten. So if you kind of like Google Ropsten testnet, you'll see that you can kind of look. There's an actual ether scan that kind of shows you all the information about that, all the different transactions and stuff there. There's a test faucet, which is going to be what we're going to be using to send real ether to our testnet account. And another thing that you'll notice in MetaMask is actually that you can go ahead and switch to the Ropsten network, and that's what we're going to be using. So go ahead and do that, and then continue on. Now, what we're going to do is we're going to be needing to have some way to interact with a network, and we don't want to actually run our own Ethereum node. And instead, you can actually use some of these services that do this for you. A couple of them that are out there are Infura and Alchemy. So what I'm going to be using is Infura. So I'm going to go to infura.io, and here you can go ahead and sign up for an account. And once you're signed in, you can go to the dashboard. You can click Ethereum, and you can see that you have these different projects here. So what I'm going to be doing is creating an example project that I'm going to be deleting later, and I'll call this my React app or something like that. And this is going to go ahead and give me the things that I'm going to need. And what I'm going to basically need is my project ID. And I'm also going to need the endpoint, which for this is going to be this endpoint right here. And we're going to be using those two things in just a moment. So now that we've gone ahead and created our test network configuration, or we've gotten that from Infura, what I'm going to do is go to hardhat.config, and I'm going to add a new config for a network called Ropsten. And this is going to go ahead, and we're going to need to set a URL, and we're going to need to set an accounts array. And this account is going to basically be 0x appended with whatever the account's private key that we want to work with. The private key is going to be coming from from MetaMask. So in this example, I have this account here. I might go ahead and create like a new account in just a moment, and we're going to look at how to export our private key, and we're going to be using it there. But for now, let's go ahead and finish configuring this, and we can come back to that. So for the URL, I'm going to go ahead and copy the URL from here and paste that here. And for the account, I'm going to go ahead and go again back to MetaMask. I'm going to go ahead and click, let's see here, create account. I'll call this test Ropsten account or something like that. Now, once I've created this account, I don't have any Ethereum there. So what I need to do is send Ethereum using that Ropsten test faucet. So I'm going to go ahead and copy to the clipboard my ID, or the account ID, and it should be now to your clipboard. And you can go ahead and Google for Ropsten test faucet, and you should find this website, and you should be able to go ahead and paste in your account ID, and you should be able to go ahead and send yourself some Ether. So once that is sent over, we can start using that, and that will show up in your MetaMask wallet in just a moment. So once you've received your test ETH, you should now see like 1 ETH, and we can continue on. So what we now need to do is export the private key for this account, because we're going to be deploying this contract on behalf of this user and on the behalf of this account. So to do that, we can go to account details and click on export private key. And once we enter our password, this is going to give us the private key. Now, you need to treat this very carefully, especially in a real project with real money. You never want to have this private key exposed anywhere. So you want to make sure that this never is hard-coded anywhere or referenced anywhere, of course, pushed up to any code or anything like that. So, often and typically what you see is these things referenced within the system. So maybe as like an environment variable or something like that. For a really, really basic testing purpose. So for like this tutorial, if you really wanted to and you're using a completely test environment, you could like paste it in, something like that. Or in my case, I'm going to say like process.env.account key or something like that. And then I'm going to go ahead and create an environment variable called account key. And I'll go ahead and open up my terminal and go to my ZSHRC file. And now that we've set that environment variable, we can now reference it as process.env.account key, and we should be ready to go on to the next step. Now, what I'm going to now do is I'm going to run that same deployment script that we ran before. And before we were running it on localhost, so now we can say npx hardhat run scripts/deploy.js, and we can say network, and we can say Ropsten. All right, so if our project has been deployed successfully, we should see that the greeter has been deployed to with the address of the contract, and we can now actually go view that on Etherscan. So to do that, let's go ahead back to our web browser and kind of look for Etherscan Ropsten, and go ahead and open that up and copy the address to your clipboard and paste it in here. And it should show up. So here we can see that it was deployed 49 seconds ago, and that's pretty cool. It's showing up. That means we've deployed this successfully, and we can see additional information about the contract itself. So another thing that we might do in a moment, maybe even now, is if we go here to our wallet, we see that we now have 0.999 ETH, meaning that we've spent some of our ETH, right? Which is pretty cool. So that's pretty great. So let's look at more of a real world use case. And a lot of times people are creating smart contracts and they have some type of tokens associated with them. So let's look at how to create some tokens. And we're going to do that in a couple of different ways. First of all, we're going to create our tokens from scratch. And then we're going to be using the ERC20 standard to create a token, which is actually what you see real cryptocurrency using out there in the wild. Like tons of cryptocurrencies that are traded, really popular ones are using the ERC20 standard. Let's look at how to actually do that. So the first thing that we're going to do is let's go back to our project and let's go ahead and create a new contract. And the contract here is going to be called something like token.sol. All right, so in token, we'll go ahead and paste in the contents of a pretty basic smart contract. We're setting the Solidity version. We're also importing the Hardhat console that if we decided to use console.logging, this would kind of enable that, but I don't think we're doing that here. We did do that in one of our other contracts in greeter.sol. And then we're declaring our contract, and this is not too much code, maybe 20 lines. First of all, we're giving the token a name. We're giving the token a symbol, and then we're giving it a total supply. Here we're saying that the name is a string, and the symbol is a string, and the total supply is a UINT, an integer. Next, we see that we have a mapping. A mapping in Solidity could be think of something like an object in JavaScript or a map in another language. It's kind of like if I wanted to say const balances is equal to address, and this needs to be UINT. That's kind of how that would work in another language. But this is kind of saying we want a balances variable that's a map, and the key is address, and the value needs to be of this type. Next, in the constructor, we're going to go ahead and set the balance of the person that deployed this contract to be equal to the total supply of 1 million tokens. And this msg.sender is kind of something that is automatically going to be available in the context of this contract. Message.sender, there's also message.value, and there's other things like that, but we're not going to really get into all that stuff. The only thing we're working with right now is message.sender. So this is going to be the address of the person, in this case, that deployed this contract. And we're going to go ahead and set the balance of the person that deployed this contract, again, to be 1 million tokens. And then from there on, we can now transfer these tokens to other people, or we can get the balance of however many tokens we have. So the transfer function is going to be doing that. It's going to be transferring to an address a number of tokens. And what we're going to first say is we want to require that the balance of the person sending those tokens is greater than or equal to the amount that they're trying to send, right? Because if they don't have that, we should not allow them to send that many tokens. And this is kind of going to be working like a check. And if this is not passed, then it does not continue on. So if this errors out, it will say not enough tokens, and there will be no more execution of this function. If this does allow to be continued to going on, like if there is enough balance there, then we will say, okay, we want to subtract the balance of the sender to be less than the amount passed in, and then we want to transfer that value to the person that we're sending these tokens to. So the address is going to come in here, and we're going to transfer it here. The amount is coming in here, and we're setting that here. Subtracting from the sender, giving it to the payee. And then finally, we have this balance of function, which is pretty basic. We just pass in an address, and this returns the value, the balance of that address. So pretty basic stuff going on there. Now that we've kind of gone through that, that's kind of all we need to set up a pretty basic token contract that does some really basic stuff. And what we can now do is go ahead and compile this contract. So I can say npx hardhat compile again. And now we should go ahead and hopefully this compiles successfully. And we should now go into our artifacts. And we should now see that we have two contracts, one for token and one for greeter. The next thing that we want to do is we want to update our deploy script here. And we can actually, copy and paste this. We can kind of copy and paste all of this actually, right? Because it's kind of going to be repetitive. We can say const token, and we can say contract factory token. And then we can say token lowercase is equal to token.deploy, but we don't want to pass in anything here. We can just leave this as an empty string. And then finally, we can say token deployed to token.deployed, token.address. And this is going to kind of take care of deploying both the greeter as well as the token. So with that being said, let's maybe go ahead and deploy this again. And we still have our localhost node running. So let's go ahead and deploy it to localhost. All right, so now we see that our greeter has been deployed again, and now our token has been deployed. So what we want to do now is create a UI that allows the user to send tokens to someone else, and the receiver of that token to also, be able to send those to someone else as well. Before we do that, though, since this token has now been deployed to us, let's go back and see if we can't view that token in MetaMask. And the way that we would do that is we can go back to localhost and go to the account that we're working with here. And what we want to do now is click add token here. And I can now click on custom token, and I should be able to pass in the contract address of what we just deployed. And click next and click add tokens. And I see now that I have 1 million NDT. And if I go back to my main wallet, then that shows up here. And I can, of course, start using those, I guess, or doing whatever I want with them. So that's pretty cool, right? But let's say we want to interact with those from our React front end as well. So let's go ahead and do that now. So I'm going to open up app.js and we'll continue writing some more code here. So, you could think that since we imported greeter, let's go ahead and also import token. And this is going to be from token.json. So we can also assume that since we had a greeter address, we're going to need to have a token address. For the token address, I can go ahead and copy this, paste it here. Another thing that we want to do is we want to have a value for a couple of things. One is going to be the user account and set user account for the person that we want to send these tokens to. And we also want to set an amount. And this is going to be the amount of tokens that we want to send. Maybe we'll kind of set that as default of like 0 or something like that. So we can type in the account of the user. We can type in the amount that we'd like to update. Next, let's create a function where we can read the coins for the currently signed in user and kind of know how many coins I have that I can now send to other people. So to do that, let's create a function that is called getBalance. GetBalance is going to first make sure that they have a wallet connected so we can read their address. We're going to then call ethereum.request ETH request accounts. This is going to give us an array of accounts. And in our case, we've only signed in with one account, so we'll have that one account for that user. Then we're going to call or create a provider like we did earlier. We're going to create a new instance of the contract like we did before. And we're going to now call contract.balanceOf, passing in the account. And then we're going to log that out. So we're going to kind of say, how many coins do I have? Let's go ahead and log that out. And then we can know that information so we can send those coins along to someone else. And then finally, we need a function for sending the coins. So let's create a function called sendCoins. We're going to go ahead and make sure that they have, given us access to their wallet by saying request account, making sure that they kind of have their wallet configured and ready to go. We're going to then need to create a new signer because we're going to be signing a transaction. We're going to be actually writing data to the blockchain. So we create a signer. We create a new instance of the contract passing in the signer like we've done before when we set the greeting. And then finally, we're going to call contract.transfer. And we're going to say, we're going to pass in the account that we'd like to send these coins to and the number of coins that we'd like to send. And we're going to wait for that to succeed. And then we're going to now console.log a message that says, okay, we've sent X number of coins to this account. And when this happens, we should be ready to go and ready to kind of test this out because that's all the code we really need as far as the actual functionality is concerned. We can now write out some of our UI. So going back to our UI, right now we have a pretty basic form for fetching a greeting and setting a greeting. I'm going to kind of scroll down a little bit and add a little more code here. I'm going to add just a break. And then we're going to have the button to invoke the getBalance method. We're going to have the function. We're going to have the sendCoins function to be able to send coins. And we're going to have two user inputs. One to set the account ID of the account that we'd like to send the coins to. And then one to hold the amount of coins that we'd like to send to that person. All right, so if we save this, we should be able to go ahead and test this out. So we've already kind of, again, deployed our contract. And we are now here in our React app, and it looks like we have our UI. So let's go ahead and test this out. So I am in the account where I have 1 million coins. So if I click Get Balance, I see that I have the 1 million coins, which is cool. So now I want to send these coins to someone else. So what I can do is I can open MetaMask. I can now choose this account 1. And I'm going to go ahead and just dismiss that because I don't really need to sign in. I'm going to copy this to my clipboard. And I want to send them 150,000 coins or something like that. I need to now sign back into the account where I want to send them from. And I'm going to click Send Coins. So I'm getting the MetaMask pop-up saying that I want to transfer 150,000 Natter dApp, 150,000 Natter dApp tokens. Not too smart. He should hold on to these things, but whatever. We'll go ahead and send those over, and we'll click confirm. And now we see that we have this message, 150,000 coins successfully sent to this address. And if I click on get balance, my balance is now 850,000 because I've just sent 150,000 to someone else, meaning that everything is working properly, which is pretty cool. Now, we've kind of gone over a couple of pretty basic scenarios. I think the next thing that people want to know about is how do I actually create some type of cryptocurrency? Now, a lot of people are using ERC20 tokens to create real cryptocurrency that is out there. So we can kind of say, if we want to Google example, like what are some popular ERC20 tokens, we can kind of see that all of these companies are using ERC20 tokens in the wild. Tether, Chainlink, Binance, all of those things are ERC20 tokens. So how do we create an ERC20 token? So what you can basically do is use the ERC20 token standard. So if I kind of like Google ERC20 token standard and maybe OpenZeppelin keeps a repository of these. Here I can kind of get a lot of documentation around it, but if I wanted to actually use it, I can either copy the code myself or I can basically install it using npm. So I can kind of say npm install OpenZeppelin/contracts. And then what we'll end up doing is extending or extending or inheriting from that ERC20 contract that we're going to be using. And ERC20 is going to have all the different methods that we're going to need for doing all of the things that we would think of a token doing. So for instance, some of the different things that come out of the box with an ERC20 token are giving you the name, the symbol, the number of decimal places. So for instance, with Ethereum or Ether, you have 18 decimals. That seems to be kind of like the standard that most people are deploying with, meaning that if you deploy a million of your tokens, you also have for each individual token 18 decimal places that you can send and receive and things like that. So you're not dealing with just a hard number, hard integer. You can get the total supply, you can get the balance of an address, you can transfer to, transfer from, you can also approve, and you can set allowances, and all of that stuff is kind of built in. So the way that we would do that is we would just install, the OpenZeppelin contracts. So we would say something like npm install, and then we would be able to now import from OpenZeppelin. I'm just going to kind of show you a quick example, but we're going to be writing a real example in just a moment. Let's say I wanted to create a real token called ND token. I could basically say forgot the license. Let's go ahead and just copy some of this stuff here. Okay, so we would have our license, and then to use that token, we could just say we want to import OpenZeppelin/contracts/token/ERC20, and then I can say contract ND token is ERC20, and then the constructor is going to take in the name, the symbol, and we're going to set that. Or, we could of course just hard code this in here ourselves. We could say Natter dApp token, and the symbol would be something like NDT, whatever. So you can do either way. And then basically the mint function is going to go ahead and mint, giving the message sender, which is me, the person that deployed the contract, 100,000 times 10 to the 18th power of these tokens. Again, remember these tokens have 18 decimal places, so we need to take that into consideration. So that's kind of how working with ERC20 is going to work. And what we're basically saying is we want to extend or inherit everything from ERC20. So we're basically saying the ND token is an ERC20 token. So we want all that functionality. And Mint is one of the different methods that comes along with that. Now, testing it on the front end is going to look a lot like what we've been doing. All of that stuff is going to be the same. But let's say we wanted to kind of just play around with some different smart contracts in our browser without writing all of this code and doing all of this local development work, just to test things out, maybe try new things out. Well, we can go to Remix Solidity, and this is an IDE in the browser where we can kind of try all this stuff out. So let's try to create a real ERC20 token. So what I'm going to do is I have this new workspace created. Go ahead and zoom in as much as possible to make sure that you can all see this. Zoom in maybe a little more. And in contracts, I'm going to create a new contract called natter-token.sol. Okay. We'll go ahead and make some more room here. And we can just paste in, this code that we had here. Okay. And I might change that version of Solidity to kind of match whatever is running here. And when I go ahead and import OpenZeppelin, what's pretty cool about this is that they're going to go ahead and install OpenZeppelin for us. So in the dependencies, we have npm OpenZeppelin. So that's pretty sweet. So we don't need to install that. So just by writing this code, we're ready to go ahead and test this out. So to do that, I can go here, and I'm going to go ahead and zoom out a little bit because I think I'm zoomed in a little too much at this point. And I'm going to go to the accounts here and see that I have an account with 100 Ether. I can choose that. I'm going to go down to the contract, and I want to make sure that I choose the ND token contract because we have all these different things that are inherited or extended from ERC20. Let's just make sure we're deploying that top level contract, which is going to in turn deploy all this other stuff. Now, if we had a constructor, we would kind of, if we had a constructor that took in these values, we would need to paste them there. So for instance, let's kind of look how that might look. Where we're taking in a name and a symbol. And then now when we deploy, we're going to need to enter that. So let's go ahead and do that. So we're going to say the name is natter-dabbit token. And the symbol is NDT. And we're deploying from this account. And I think we're ready to go. So let's go ahead and try this out. So I'm going to click deploy. And if the deployment is successful, we should see some logging out here. Go ahead and pull this up a little bit. And you should see that creation pending and then like a success message if it was successful. So that means this was successful. I can also go down here and see that I have these deployed contracts here. And the token here has been deployed. And I'm now looking at all the different methods that are available for this token. So I have these transactional methods that are orange. And then I have these green methods that are essentially reading, so no gas needed. So let's go ahead and click on total supply, and we see that we have our number times 10 to the 18th power. We have the symbol NDT, we have the name natter-dabbit token, we have the number of decimals, which in our case is by default is set to 10 to the 18th or 18 decimals. Now this value of decimals can be changed as part of your deployment. So like if you want to have 16 decimals or 19 decimals, you can do this. And you can just go into the documentation actually for the ERC20 token and actually look at some of the documentation for OpenZeppelin because I actually submitted a pull request to kind of fix some of the updates that have happened recently. But there you should see a pretty easy way to override the decimals method to kind of set the decimals. So we can also check the balance of. So I can now check the balance of, for instance, my contract. So I'm going to go ahead and copy this. Do that, and I see that the balance of me is this much. And let's say I want to transfer to this address. And I can kind of put the amount here. So I might say some huge number, I don't know. And we'll try that. And if I get my balance again now, then it's a little less than what we had before. So the transfer, is successful. So we were able to kind of send that. Okay, cool. So I think that's it. So I think that with everything that we just covered, it's a really great overview to kind of go over how to build out these full stack Ethereum apps end to end. We went over, creating your environment from scratch. We went over initializing a new Hardhat environment. We went over creating a local Hardhat node and network, deploying to that network. We looked at how to deploy to Ropsten test network, how to get, some fake ether sent to that, and we created a base token from scratch. We also created an ERC20 token. I think we covered a really large number of topics here. This is the kind of getting started guide that I wanted when I was first getting started with this tech. So that's kind of why I created this. So hopefully that you learned a lot from this video and you kind of, have gotten further along in your journey learning all this stuff at this point. So I hope you liked this video. If you did, please like, subscribe, and share all of the stuff that I'm doing here. And if you have any ideas for new future content, please let me know in the comments. And until next time, I will see you around. Thank you so much.